I'm Shayna Solis, co-founder of Navteca, and I think I know some of you from ESIP from the past or from EGU, um, and the PI on a NASA wildfire grant, looking at immersive technology and conversational AI for understanding wildfires. And it's nice to see you all.
Guy, you want to go next?
Yeah, I can go next. Guy or Guy Schumann. I don't mind which way you pronounce my name, actually.
Which do you prefer? We'll try and get it right.
I always prefer Guy, yeah,
Okay.
but I don't mind. I've been living in the UK, so I'm originally from Luxembourg, but I've been around in the UK, US quite a long time. I got to know a lot of NASA people, including David Green. David, at his time at NASA, funded a lot of flood projects for teams that I was involved in. So my expertise is actually flooding and flood disasters, looking at Earth observation for managing flood disasters. And I still got a US affiliation with companies as well, but I moved back to Europe after COVID because it was very difficult for me to get easily back to the US because of travel. So I opened my own company as well in Europe, but always kept the US network very close to me. And in Europe, I founded my own company called RSS Hydro. So we're doing a lot of hydrology, looking at flooding, and also, well, we do wildfires, but I present flooding today, and we're using a lot of ML satellite data, but also forecasting models. We build a lot of the open source community models that are still out there for now, but yes, so that's me. Thank you. Looking forward to this session.
Nice. I guess Everett?
Yes. I'm Everett Hinckley. I retired from the Forest Service back at the end of April 2025. I was a co-chair of the Tactical Fire Remote Sensing Advisory Committee from 2004 to 2024, along with Dr. Vince Ambrosia, Birgit Peterson, and Mike Pavlonis from NOAA. And I'm trying to stand up a new forum for remote sensing support to wildland fire, even though I'm retired. So I'll talk about that a little bit more later. But I'm happy to be here today. I'm not presenting this morning, but I think I am scheduled to present in the afternoon section.
Great. Let's see, Michael Shaw?
Yes, hello.
Hi there.
Hi, how are you?
Good. You want to introduce yourself?
Oh, yeah. I'm with a company called iSciences. We're contracting with various federal agencies and entities. I'm working most closely with NIDIS, the National Integrated Drought Information Service, out of NOAA and CEI in Asheville. I'm actually joining you from New Hampshire. So I work on a lot of drought kinds of questions. We work on drought.gov, the government website.
Great. Let's see. Marge?
Hi. Can you hear me?
We can.
Great. Hi. My name is Marge Cole. I am with Lune AI. My business partner is Nadine Alame. And we started this advisory and consulting business this past year in 2025, concentrating on geospatial AI and the advancement of it, and how businesses, academia, and government can implement geospatial AI within their architectures to, have a greater impact and advance their capabilities. And work those capabilities into a greater, kind of strategic effort globally.
That's great. I think we probably all have 1 degree of separation at most from Nadine, but anyway.
Yes, yeah.
Dr. Smith. Hi, Marge. We see you now. Dr. Smith, you want to say hello?
Easy.
Going once.
Hello.
Oh, there you are.
Hi. I'm Smita Haridasan. I work as a postdoc at Westchester University and Pennsylvania. I work for I create open source codes for volcano modeling,
Nice.
mantle modeling.
That sounds fun.
And my PhD research was on wildfire detection using AI models.
Very good. Everybody has a connection to wildfire, even the volcanologists and the soil folks. Let's see, Rachel, you want to go next?
Sure. Hey, everyone. Good morning. My name's Rachel. I am one of the ESIP fellows this year. I'm a postdoc at Cal Poly Humboldt. My work is mostly in mentoring undergrads who are new to data science and teaching workshops. My PhD work was in modeling forest climate dynamics, and I worked on urban forestry, but I also worked a little bit with wildfire modeling, and living in California, always thinking about wildfires in the back of my head. So I'm excited for this session today. And I'll pass to Maddie.
Yeah. Hi, everyone. My name is Madeline Allen. I'm a PhD student at Cornell University, working with Scott Steinschneider. I'm also an ESIP fellow this year with Rachel. And my research largely focuses on forecasting different hydroclimate variables, mainly streamflow. And I've started kind of pivoting much more into the deep learning space recently. And yeah, excited to see what y'all have been up to.
Great. Who did I miss? Alex. Can't miss Alex. He's my boss.
Hi. So I'm probably probably not the scientist in the room, but I'm one of the more visionary doers on the ground. I spent 10 years in Afghanistan with the U.S. military. I shut down the burn pits at Bagram and Kandahar. I built Afghanistan's environmental infrastructure. I didn't know at the time that I was doing that. And now I'm back working with the firefighters on the ground in Southern California and Colorado, attempting to solve this global technical problem and looking forward to seeing how we can collectively come together, bring our expertise, our knowledge, and our understanding of this problem and solve it. This is a huge task, and not one company, not one academic institution can solve this. So I'm really looking forward to our continued discussions and collaboration after this as well. So thank you.
And it looks like David Green has been able to join us. So I'll pass off to David. We've been tap dancing in your absence, but
no, I'm glad you were able to deal with the hazard. Sorry about that. Little family issue, and then I had trouble logging back in. So welcome everyone, and thank you. I heard Alex was, I guess, finished your presentation, Alex. Is that correct?
No, we're just doing intros all the way around.
Oh, you're just doing intros. Okay. Well, I should let you continue. And just by way of intro, for those who don't know me, I spent my career at NOAA for many years in the Office of Science and Technology for the Weather Service and a number of capacities there, and then went over to NASA to set up their disaster risk and resilience program, and obviously experience with ESIP as an ESIP partner. And I'm glad you could come together today for those of you around the world and discuss what I thought was a really important topic for ESIP and for our community to start stepping into. So with that, I'll just turn it to whoever was next in the introductions.
We hadn't decided the order, so I don't know who you wanted to have go first in presentation.
Okay. So has everyone introduced themselves? Everett, have you had a chance to introduce yourself?
Yeah.
Yes, I did.
Yeah, I think we got all introduced, unless I'm...
I haven't had
Interesting. You introduced yourself?
I think Rob, do you want to?
I think I missed Rob. Sorry,
we missed one.
order
Yeah,
was
Rob.
Yeah, so I'm Rob Carroll. I'm the founder for Terra Analytics, and I'll get into a bit more about my the research I've been doing and work on it. But I take a little bit different approach. I'm looking at the individual property level rather than the region or global type of approach, and applying generative AI to help out with homeowners and insurers looking at how they can best reinforce or remediate their properties for wildfires, hurricanes, any kind of hazard that would occur for real property. So excited about having a chance to talk here. Very much interested in the other feedback as well.
Okay. And Marge and Shayna, you both had a chance to introduce yourselves? Okay.
Yep.
So the intent here in the first part was really to showcase a variety of different perspectives, all within the hazard kind of case study, but everything from the ability to capture data and understand what to do with it at certain scales, whether it was in a WUI, high-res super resolution, or global scale, to go between those, to mix the data to understand what the nature of the hazard was or the peril, but also to translate that into the nature of the risk, to understand where the roles are of your particular technical perspective so that we could have a part two discussion, which was really to start to address some of the highlights that each of you have seen in terms of the state of the art of what's capable, some of the barriers, some of the concerns, and what steps should be taken. And I know I've had a pretty vigorous discussion with most of you, everything from, hey, we need AI data standards to better catalogs, to deal with data poisoning, because we can't have that for the case of hazards. So let's go back to Alex and to Mike and hear what I think is a more unique perspective and technique and technology that they're applying to their fire AI approach. Then I'd like to go to Robert to kind of go into this insurance property type of dialogue of how you scale that. To Shayna to talk about your perspective and how you've worked on fire and flood and earthquake, and the idea of how do you ask the right questions from conversational AI to how you visualize things and what's possible and not possible. To Guy then to bring in some of the perspectives from his European work, but also he's worked around the world on national projects related to the flood, as well as flood to fire to debris. And Marge, you've worked with me, and others from the geospatial perspective, and know that it's not all technology. Sometimes it's the people. Sometimes it's the funding, sometimes it's the collaboration. And that'll position us for the second set of discussions right after the so-called lunch. So with that, go to Alex and Mike, the fire scorer.
Mike, would you like me to?
Yeah, if you could start up.
Okay. All right. So we green light to start presenting?
Yes.
Okay.
I think you need to share your.
Yeah.
Or do I pull it up?
No, it's me. All right. Can everyone see my screen?
Yep.
Great. All right. My name is Alex Momond. I am the CEO of FireScore. I'm joined today with Dr. Flaxman, our CTO. And I want to share my first interaction with fire, which was in Afghanistan with the burn pits at Bagram Airfield and Kandahar Airfield. So everything that you could imagine was being burned. Prosthetics, food waste, wet food waste from the DFAC, munitions, hazardous waste. Everything was being burned every day with TS1 jet fuel. And the issue when we spoke to the garrison command is that, Alex, we do not have the infrastructure inside the base. We do not have the landfills, the wastewater treatment plants, the hazardous waste treatment facilities, even the area to do the composting because it was a really important airfield where they couldn't have all the birds surrounding them. So I used some really good castor oil and grew out my beard, and I went outside the base and had some of the best kebabs of my life and ended up building the infrastructure, ultimately shutting down the burn pits that were causing harm to the warfighter and also to the local populace. The plumes don't just stop at the perimeter of the base. There were villages adjacent to the base. And so we repeated that. We had great success there. And then we went to Kandahar. Then we went to Tactical Base Shorub in Helmand. And we ended up capturing the entire market in the country. And we made amazing progress, especially with the local community and getting them involved and building the recycling factories. So that was my first interaction with fire. And unfortunately, due to the Taliban takeover, I had a forced exit back to the United States, where I grew up. To the Bay Area. And naturally, I became curious, what's around me? Is there anything I can do to help? And so I met the fire department in Los Angeles. And there was a different story being told this time. And it was, we can't really see the hazard. And so you can't understand this through a Zoom call. So I fly over to LA and I spend about a year on the ground with the firefighters to really see, what's happening on the ground. And the technology that is currently presently available for the firefighters, it dates back to the 70s. It dates back to the 90s. And although it does a great job in the forest, or a good enough job in the forest, when it comes to the urban setting, it does very poorly. And we recently saw that in January with the fires in LA. And so we started collecting data before January. Unfortunately, we weren't able to get the intelligence on time to the firefighters, and we're still working that out. But I'm really excited to share about what we're doing, because this is what really matters. It's the lives that are being lost, and the fact that we have technology available to us today that can prevent this, so that an urban conflagration that we just witnessed, we can at least understand what the impacts will be, and through simulation. And Lindsay Horvat's office, county supervisor of LA, said it pretty right. Even if we had every single fire truck in the nation, every single firefighter, we would not have been able to stop the fire. The flame lengths were incredibly high on the ground. Aircraft was grounded. This was a true disaster. And so we built firescore.ai because fire moves faster vertically than it does horizontally. And I noticed that everything that was being done in 2D was only covering a portion of where the risk is. And my goal here is to introduce a geophysical AI, an AI that understands our geophysical world. And we start with fire. And what better way to do that than to do that with the leading 3D graphics that's out there in the world? What better way to do that than capturing high-res LiDAR on the ground and being able to match that data and validate it with firefighters on the ground? From fire, I envision this geophysical AI being able to support other industries as well, but we're going to stay very focused and crack the code here. And being able to take a look at properties and understand geometry, have an AI understand the distance of vegetation to a structure, have an AI understand that this fence has been treated with phosphorus or not, and being able to have the firefighter on the ground validate all of that. This is the goal of our platform, and I want you guys to listen to the firefighters themselves.
We're here to actually
how we're using it today.
Come into 100% compliance with our fire inspections this fire season. this is the wave of the future in terms of fire inspections. Not only a game changer, but really a golden egg in our industry in terms of fire inspection software.
City Fire Department, Steve Hamilton here. We are using some multispectral and hyperspectral cameras. So this information is going to go through a program called Gaussian Splat. We're going to end up sending that link over, and what that's going to allow everyone to do is look at the before the brush clearance and after the brush clearance and really check the vegetation and see the difference.
It's really just an amazing tool that is really backed with a lot more technology than what we're accustomed to, but I think that it's the way of the future for sure.
And there are amazing scientists that are out there that are doing incredible work, and I know that many of them that I personally have met and have interacted with are probably on this call or watching. And you all know this better. You know the science better than I do. My job is to be able to bridge the gap between those on the ground and bring the technology that's available today and be able to use the state-of-the-art technology, probably not to capture fictitious creatures on an iPhone, but rather to capture invasive vegetation throughout LA County and take this technology that we build today and be able to use it in other areas that have the Mediterranean climate, be able to go to Portugal, south of France, Greece, Spain, and be able to support those people out there as well. That is my goal. And the traction for me so far has been very clear, working with departments and cities. And these are the champions that are out there. They want a change in the way things are being done. And lastly, I ask you all to join us, and I look forward to seeing where we could collaborate further. And Dr. Flaxman, our CTO, will make his presentation a bit more on the technical, and I look forward to seeing how we can best work together. With 2025 as a wrap, we move on to 2026, and what we develop is going to be the GPT moment for geophysical AI. Get ready. And thank you.
Thanks, Alex. And I think we have Mike now to dig more into the technical detail. But you've certainly set the vision, and I think it's true for all nature of hazard that it has to connect to the people, which is where I've been attracted to the approach you've done, whether it's high-level decision makers or those really in the field, on the ground, who are face-to-face with the reality. And where is AI going to help us do what we've promised for many years, bring this kind of Earth system knowledge together? Whether, as you mentioned, it's knowing that that fence was treated with phosphorus, whether it rained last week, whether those roads are clear. We've talked about bringing all that data together. It comes in different formats, different volumes, and more of it every day. But it's now beyond the human capacity. And so there's now a big push for physical AI and automated AI, assisted AI. And what's true, what's fictitious, is what we need to face up to. And I think this is why I wanted to have it in this community discussion. So, Mike,
great.
Are
Thanks,
you ready?
David. I am. Are you seeing my screen?
We are, and I also invite others here, especially those who are technical, to dig into this with Mike on some of the realities. So Guy and Shay and others here who I know are very technical in this, don't hesitate to unearth or dig under this to get into your geek speak, which is beyond my capacity. And that's true for other people here, because I really want to make sure we're unraveling what's possible. And many of you are looking at things like what's going on in gaming that we haven't used in the kind of the real world. And I think this is a little bit of a new way of doing things. Thank you. Over to you, Mike.
Exactly. Thanks. So I thought I'd start off with a little bit of kind of reflection on practice. So my own practice on this started in back in the last century, in the sense I did my dissertation starting in 1998 on wildfire in Southern California mountain communities. And this is an image from my dissertation done on some big expensive SGIs at the time that Harvard was nice enough to lend me, and yet kind of part of what we're trying to accomplish hasn't changed that much in 25 years. I was worried about structural ignition then. We're still worried about structural ignition, as we should be. We're still worried about fire behavior. The methods, though, have changed quite a bit. And so upright, sorry for it being small, but just to give a general sense of it, is our current pipeline, behind the scenes for how we're delivering wildfire risk information to fire departments. But the things that are really quite new include the fundamental geometric representation. And so I used, Alex showed you some beautiful ones, but I used a grainy one lower right just to show a little bit of what's actually going on somewhat behind the scenes. So we're using Gaussian splats as a data source and as an integration method. And the reason we're doing it is because that can replace photogrammetry in capturing vegetation detail, basically preserving more detail in fine detail, but also lowering capture cost because we're able to get quite a far away with structure from motion, and then to anchor that with USGS LiDAR that we have almost wall-to-wall in the country. And so that gives us a combination of ability to scale and geometric accuracy that we didn't have before. And those of you that know fire know that small details matter, or relatively small details matter. It's not the redwood tree, it's the needles from the redwood tree that have been accumulating on your roof for 3 years that are usually the issue. So there's a fundamental new data type in town, Gaussian splats. It still needs all of the analytics that we need on every other data type. And so connecting and keeping that in an analytics pipeline is a challenge. But there's also been kind of a major move in embeddings to characterize different aspects of the landscape using the concept of embeddings. It started off or got more popularized with language embeddings, but Google DeepMind and Clay, to name a couple of initiatives, brought that to physical pixels and remote sensing data. A lot of it converging in 2023, not long ago. And since then, we've started to see the emergence of joint representations that are both so-called vision language action models that have physical tokens aligned with semantic tokens. So oak tree combined with the voxels or Gaussian splats or LiDAR points that represent an oak tree. I guess simultaneous to that, we have the emergence of super resolution or diffusion or GANs that are, I'd say, starting to blur the line between primary data and models, because you can think of them as a very sophisticated interpolation technique. They match the boundaries of the pixel you observed, but they make up interior detail based on prior knowledge. And so they can be wrong. They can't be wrong at the boundary or beyond the boundary, but they can be wrong within a pixel. So it's, I think, a unique opportunity as well as challenge for science communication. I guess I was just trying to pull this out a little bit for conversation in terms of what's new and different. So the things that I feel haven't really changed or haven't changed that much include what I'd call the usual suspects. So we still need open data standards. We need it more than ever because AI models require a huge scale of data. We still need stratified random sampling. AI models are not immune to sampling bias. And so, that's a big issue these days still. We still need notebooks for replicability or other means for scientific replicability. That really hasn't changed. The techniques for delivering it change a little bit year to year, but it's still there. And then errormetrics, I would say, are fundamentally unchanged. I mean, we're still using mean absolute error under the hood in a lot of things. There are a few, newer error metrics like intersection over a union that are emerging. But the real thing with error metrics is just that they're getting packaged up in combination with basically reference open source data and multiple metrics into what the 20-year-olds are calling evals these days. Here I am in Silicon Valley, so everybody talks about evals all day long. Well, it's nothing unfamiliar to a scientist, but it is packaging of things that traditionally have not necessarily been packaged, and that's been at cost to replicability. So I think that's progress. The new kids on the block, I kind of mentioned here. Here's an example on the right of image super resolution. This one done on NAPE, can also be done on Sentinel-2, and we're doing both. Just to give you a little bit of a visual if you haven't seen this stuff before. And I guess the native ability of the new models to go across traditional modes of data, I wanted to highlight. So we're routinely using combinations of optical and SAR, for instance, because they complement each other really well. And so that said, kind of pulling back briefly, what are the collaboration and policy implications of all of that? Mostly for conversation, but I think we have to deal with new types and formats. Obviously, didn't mention it earlier, but kind of cloud optimized formats that I know this group has worked on for a while are rapidly moving mainstream. So don't need to convince people so much anymore to use COG. Other ones are coming along, and there's kind of mainstream IT adoption of formats that support geographic coordinates. So that's kind of underway and might solve itself. At least there's a lot of people pushing to get it solved. And it does include a public policy component of basically getting older data sets updated so that they are cloud optimized. And my favorite from the last few weeks was ER5 from European Space Agency. So basically climatology data that you used to have to download. 2 years ago, I did a project, and so I remember it was something like 384 gigs of data for each step, and I only needed one variable from one atmospheric level, and so I was, being forced to download incredibly large data sets just to get to one piece of that data set. And ESA, to give credit where it's due, has reprocessed their own data so that they're able to deliver you a single variable for a single time point and a single spatial boundary very efficiently. And that just, it's a tide that lifts all boats. But if we look at Gaussian splats and embeddings that I was just talking about, we're still in pandemonium land, right? So there are efforts underway to include these in standards. I was at SIGGRAPH this summer, and we talked about Gaussian splats and their standardization with all of the major parties that should have been in the room and were. But because that is coming from the graphics world, you kind of have to reintroduce the importance of tiling, of level of detail, and especially of geospatial referencing. And so, it's a broader community that is involved in these other formats. And so the harmonization won't be maybe as easy as it was for OGC on data formats that were more specialized. And we're kind of having to negotiate with a broader community. So it's good news, bad news, right? The data formats are going mainstream, but that means in order to get a standard across that gets georeferencing right, you have to explain how georeferencing should work to somebody that's not used to thinking about it. And then lastly, a change that's kind of fundamental and fun to think about and work with. You saw a few examples of it. But in the AI world, basically every frame of a video or every image is basically a portal already into 3D. And so the capabilities are there. For instance, Facebook's SAM depth anywhere model or semantic segmentation models can take even monocular 2D views and estimate the depth of the pixels. However, there's still a need for open standards to organize that data in a useful way so it's interoperable. And right now it's not. And so I gave the example from MathWorks, which was the earliest I saw of this paradigm. But in a single camera perspective, you not only have your kind of traditional optical payload, but you also have a depth map and semantic labels that need to be carried in register and in frame. And so there's a start to this using the spatiotemporal asset catalog and its oriented image extension. That gets you the camera stuff, but the layers part of it still hasn't been standardized. So anyway, in some ways, this is new problems, and yet this group has already seen very similar problems before and solved them. And so I'm optimistic that the stuff can be solved. It's just that we have pretty much everything I just talked about was from 2023, so 2 years, and we've seen more fundamental changes in data types and model capabilities than in several decades before that. So the velocity of the changes to this stuff, I think, will probably be the challenge. I think we know how to do this as a community, but we need to figure out how to do it quicker and that in itself quicker and with a broader community, I guess, would be my summary.
Okay.
So that's all I had for you.
Thank you. Any questions from your colleagues on here? If there is, just unmute and share that. Otherwise, I'd like to get Rob started and teed up.
Yeah, can you see my screen? Oh wait, hold on. If I hit the share
button,
you,
not your screen.
There you
go. How's that?
There we go. Thank you.
Perfect. All right. Do you want me to start off, David, or do you want me to?
Go ahead.
All right. Yeah, so I'm going to talk a little bit about the work that I've been doing for the last year related to property risk score. My background is really around aerial imagery for the last 20 years, manned aircraft primarily, and the application of the traditional, computer vision type of analytics, returning back, predictions on the inferences for, roof condition, those kind of other pieces. And one of the things I saw through all of that was really limitation in two aspects of it. One is that it was very hard to get accurate information out of those systems just from that one data source. And the second part was that it really didn't make any sense to a person as to what did an 8 mean versus a 7 versus a 6 on a score chart necessarily. So the ability to actually implement that into an actionable insight or an impact was really a part of it. So the organizations I've been working with, where I've been involved in, really been around dealing with these disasters and the growth in the last many years. And I don't have to go through all this. Everybody here, I'm sure, is familiar with this. But in the insurance side of things, they're seeing a major issue. 2025 wasn't bad, but 2024 was really bad for weather-related claims. 93% of the $140 billion in U.S. disaster claims were weather-related. So there really needs to be better insight in order to help minimize that as much as possible. One of the things I've always talked about is, climate is a global constraint, but risk is actually local. The risk to a property, and I've seen this in so many post-disaster, areas where we've gone in and looked at the imagery or the data reports coming out of it, and there'll be these, I call them the lottery winners, these buildings that survive a wildfire or a hurricane or a tornado or other things seemingly unscathed while all the buildings around it are destroyed. And really what that indicated was that there are ways to fortify, to mitigate these risks, and that a lot of organizations or a lot of people in the organization don't have access to that information. So one of the analytics came back saying that only 1 in 10 homeowners have access to property level risk information. What does that mean about their property? And that's really kind of the driver that I was looking at for the system. The one of the pieces that we've sort of built into that is that for every dollar spent on property mitigation, it can save up to $13 in disaster recovery. So this really is an opportunity for us to reduce that $140 billion worth of damage by investing a little bit of that up front, and also the other kind of residual benefits of improving the roof lines, the vegetation setbacks, all those kind of aspects of it as well. That really is a big piece of potential for us to reduce that damage, not just monetarily, but also to those lives that are impacted by these events. So what we developed was something called a property risk score. What I looked at was, using any one modal of data coming in, whether it was GIS layers or imagery or elevation data, or even just text or photos from a camera, something like that. They were effective for getting us to a certain point historically. But what I discovered the last year, working on a grant that I received from Amazon, was that the ability to start to apply spatial reasoning that the generative AI tools are able to bring to market now really helped us be able to address that. So one of the big aspects that we're able to bring in is the multimodal aspect of generative AI. So I can feed it information from different disparate sources, different resolutions. It can be analytics, the results of it. It can be raw data sets. And the generative AI is able to reason against that data set and then bring that in and provide a property risk score. The important thing that also comes out of that generative aspect is also that report or that information coming out can be kind of customized for the audience looking to receive it. So it can be very analytical for data science applications, or for a particular homeowner or for an underwriter. We can add additional layers of information into that to explain why a property scored a certain level or what could be done to mitigate the potential disaster. So those are some of the aspects that we're bringing into this that aren't available currently with the more legacy ML type of tool sets that are in that. So a couple of things that I looked at over the last while around this was really not just trying to apply, feed the image into ChatGPT and then have it spit out something. That you can do that, but it doesn't really result in a better product or better piece of it. The important founding that I came across in this was really around the ability to use groundings and be able to pull dynamic data sets in from whether it be property reports, MLS report data sets. There's a lot of different data sets that are available now and searchable by the system. And the more that becomes available, the better the results are that I'm able to use, because that helps ground the data sets that we're going through that. And the reason for that, we're looking to eliminate hallucinations. So quite often I would get a report on a rooftop and I would say, what is the estimated age of this rooftop? Because that's a crucial aspect for underwriting and insurance. And the type of material that was used, or the type of the design of the pattern of the roof, may make it appear that it looks better condition than it really is in aerial imagery. And I think Dr. Flaxman showed a couple examples of the resolution of satellite and aerial imagery. We're not down to being able to pick apart individual granules on top of an asphalt roof. So to really understand wear patterns and the aspects of that, we're not quite at that point yet. So we can start to build those out. But the ability to pull in the actual permit data that was pulled for that information and bring that in and help build the groundings around that helped out immensely in improving the results I was getting out of the system, reducing that hallucination level, and really driving out to a different data set that was usable by the organizations. The other piece that I also came across that was important, as I've sort of touched on this context first, so injecting those building codes, those property records in before we start to run through and do some of the CV type of applications helped out in kind of guiding that across that and building out a guardrail that it can't be a 5-year-old roof when the permit is 20 years old kind of situation. The other thing that was really important in the finding was also the chain of thought. So the logical sequence of how you go about prompting the AI and go through the generation is actually more important than some of the content of the data being brought in. So the steps and the prompting around that are really important and a crucial piece of this. So we want to make sure that we're not just, if you set up your prompt to just ask for a report on a risk, I found this out early on. If you put giving a risk score at the front end of it without actually having to go through and analyze the roof or the property around it, it will pull a generic risk out, but not without taking those into account. So the structuring of that, looking at the environment, looking at the building geometry, the regulation, and then doing the risk scoring based on those previous discoveries in an agent form made a huge improvement in the accuracy and the results that were coming out of that. And the last part, I mentioned agents, but also the ability to build out multi-agent and have it go through and actually do an audit post to do a sanity check and flag that has been a big advantage to help reduce some of the outlier issues that would come in with any of these kind of data sets we're going to have. There's always going to be issues around occlusion because of vegetation or cloud shadow, other types of applications that may come in and cause limitations on that. And then finally, the ability to have a human in the loop to identify that when the confidence levels are low, have that flagged out and make sure that we just don't send off an estimated score based on poorly derived inferences from that. So those are all pieces that have been implemented into the system I've been building out with this. And I think I've jumped ahead here. Yeah, so what we end up with then is a personalized property report. So I look at the individual parcel of land. I don't look at the entire neighborhood or the city or state or any of those kind of levels of detail. We bring in those kind of levels of information. My system will go out and reach out. Currently, it's pulling in data from the Forest Service or from NOAA and bringing those in based on zip code or other kinds of levels to it. But where my system becomes valuable is actually looking at the individual structure. In this case, my first level has been working on the roof health of it. So things like, in this case, there's a tarp on top of this roof. There's missing shingles. The ability for the system to go through and identify that and provide that information in an easy to understand report really helps break that down and make it available to homeowners or to property specific risk organizations across that. So you'll see this one, the type of reports I'm getting out are, the subject property, high risk due to advanced shingle aging, visible evidence of a recent roof leak because of a temporary tarp, and the complex nature of the roof. There's some dimensional aspects of that get involved in what's called a dead valley, which is a big issue. This is in upstate New York. So a lot of snow penetrations, water infiltration, high wind events can also cause those kind of locations to come that. That's not something you can build a computer vision model to be able to identify that. It's a logical construction of the geometry of the roof that results in that, not necessarily what does the roof look like, but how is it constructed and what's the orientation to the wind lines, those kind of things with that as well. So all of that goes into these reports. This is a really bad example, mind you, but it also gives you kind of a score across that 1 to 100 type of system and the feedback across that as we go forward. So that's kind of where I am right at the moment with the system. Currently, like I said, we're rolled out the roof analysis API, so we're able to deploy that for any location in the United States. And then the next level I'm looking at is moving from the roof into some of the other building envelope aspects, doors, windows, those kind of siding, those are also big contributors to it. And then the last one would be building out a complete property risk and analytics piece to it. So right now, looking at roof, major contributing factor. But as we go through this, we'll actually be able to identify other contributing factors. There are indicators around, the amount of money that's invested into landscaping has a correlation to how well maintained the rest of the house is. So there's indicators like that can be used to identify risk or lower risk potential based on that. So those are all things that can be kind of built into the model going forward as we look at this. So that's kind of just a quick overview of what I've been working on, a little bit of where we are. If you're interested in more, that's my website up there. You can reach out or the phone or email at the bottom there. Feel free to go through that. But thank you for the time today.
Thanks, Rob. And thanks for pointing out things like the process and the sequencing of collecting information and how that's uniquely enabling or not in the case of AI, and a little bit of where you're going from rooftop to vegetation to full property issue. I know part of the scaling is they can do everything right on their single property, but what happens to the neighbor can also be more of a serious issue. So I assume that's somewhere in your future is to scale up the types of data to understand those dependencies. And perhaps some of the people online here have some views on those types of scaling issues. And I wonder whether you just had a quick comment about how proprietary is that property data? I can certainly see the value of really showing the composition, we even had, we've had the Home Depots and the Lowe's and others saying, should we be offering up their data when they go out and buy the materials so that people know what's going to be built? Any comment on getting access to that kind of a data?
So I think you mean kind of in the aspect of roll up across the areas rather than on a specific property. Is that what you're asking?
Well, there's two aspects. One that rolling it up to understanding the community scale, and the other is just how available is that data on composition and built structures and codes and things. Can you really get access to all that data? And is that an opportunity or still a challenge?
No, it definitely is a challenge. So there's some inferences of, year built's fairly common across the different data sets. The problem we run into as you get into this, you'll dig into it, is that the property records are typically maintained by the county. So there's 3,100 counties across the U.S. There are 3,100 different organizations with different data schemas, different ways that they've exposed their data, good or bad or otherwise, in that. So it's very spotty, and I would say it's not AI ready in most cases. So it is a challenge. But one of the things, once you have the ability to pull those data sets in, and the major metropolitan areas typically have it. Once you have that, that really helps ground that data. What I've been finding is that oftentimes there'll be new roofs put onto buildings without permits pulled necessarily. So we can actually go through that. I mentioned around the human in the loop. That's where we have to come in and kind of use that. As the building report says that it's there was a roof's 20 years old, but looks like a brand new roof on top of that. We go through and kind of identify that through that. And I think somebody just mentioned a comment. I'm not able to dig underneath dig in the attics or get underneath the crawl spaces, that kind of information. You still need people, boots on the ground for that. And I think there's an opportunity to use AI for that as we go forward. To put it on an edge device to be able to go and document these as you go through a property, to document that information. Is there ember resistant venting on the eaves? Is there proper double pane windows? All those things are not available from either street view or satellite, but we can get a long ways with what we have right at the moment, and we're always looking at improving as we go forward.
Thank you. So there are people adding questions into the chat. So I encourage everyone to keep an eye over there for some specific questions and opportunities for dialogue. For the time being, let's move on to Shay and Navteca. And I think that'll follow very nicely with this progression of thinking about what tools are available to visualize, to interpret and map. What kind of information can be merged together to start to understand, interpret, and ask the type of things that may make a difference to an actor, a decision maker. Shay, thank you.
Thank you. Can you see and hear me?
Yes, we can.
Great. So I'm going to present some work that's specifically focused on wildfire, but I will preface this to say that we've also done a lot of work with flooding, earthquakes, multi-hazard, some of it with David when he was at NASA, and have continued to look at lots of different ways that our immersive technology approaches for geospatial and scientific data. And then also now through conversational AI, which is going to be a little bit different take on the AI component and how we can better understand geospatial data and risk using these technologies. As I mentioned during the intro, I'm the co-founder and CEO of Napteca, and we've been exploring these technologies for over a decade. So we've really built up a lot of expertise and thought leadership in the area. As you know, we already know we have more data and information than ever, and yet we aren't necessarily making better decisions. It's harder and harder sometimes to actually connect the dots and make data-driven decisions, even though we are somewhat inundated with information. Especially at the community level, there's a real gap between the science and research that's out there and the sort of boots on the ground decision making. And so one of our goals at Napteca is to use technology to make that risk information more relevant, understandable, and above all, actionable. We've done a lot of research over the years, specifically into using immersive technology. So we started with virtual reality headsets, again, over a decade ago, and looking at, what you could do that was outside of gaming, but using game engine technology, the same technology that's used to make virtual worlds for games and all of the interactivity that comes along with that, and applying that to the science and geospatial world. The image here is actually showing a project that we did with the NASA disaster program and showing surface displacement after an earthquake. We successfully connected their disaster portal and to our VR framework, and within hours of data being published on the portal, we were able to show that in VR. This was a huge accomplishment at the time because nobody else was really working on, getting real-time information or near real-time information into headsets. So again, really creating a lot of thought leadership around these capabilities. Just for the sake of time, I'm not going to go through a retrospective of all the different work and projects that we've done. I'm going to focus specifically on wildfire. But if you do have an interest, I know some people mentioned flooding and earthquakes and some of the other hazards and such that are out there. Feel free to reach out and love to, chat with you. So today, just again, kind of really focus on the wildfire risk. We've been looking at this specifically on a couple of different levels. So one is that near real-time information and taking data from across many different data sources and bringing it into the game engine environment. In this case, we're using the Unity game engine. And then we've also brought in a conversational AI assistant, and this is our own technology that we developed called Voice Atlas. We actually released this software many years before ChatGPT and some of these other software that have come out. We've released Voice Atlas during the pandemic, and it's a way to limit the data and information that the large language model is able to look at. So it gives you the peace of mind that the information is only coming from trusted sources that you as the knowledge manager control. It also eliminates hallucinations, inappropriateness. You don't need to do any prompt engineering and such. So I'm going to show you how that comes into looking at disaster information specifically and how it can really enhance some of the visualization work that we're doing, but also, again, just sort of thinking about how do we now synthesize information and put it into formats that make it more understandable for people, whether that's visual or through being able to explain difficult concepts, algorithms, and information at a level that people can understand, meets you where you are. So I'm going to go over a couple of different case studies. The first one was done through an initial grant from the NASA Wildfire Program, and we looked at the Hermit's Peak fire that occurred in New Mexico back in 2022. These are just examples of visually how information is often looked at, these sort of 2D maps. This is showing the red flag warnings for the day that a prescribed burn was set by the Forest Service. It was within all of the approved limits, so there was, no culpability in that sense. And then looking at, 3D map of what ended up being the fire perimeter when that fire unfortunately did get out of control due to erratic winds that weren't foreseen. And then, of course, typical imagery that we might get from, different satellites, drones, Earth observation. So what we're doing is we're really trying to combine all of these types of information. The other piece of information that we get is, in a text format. So in this case, this is the after action report from the Forest Service looking at this incident. And what we're showing through this case study is really how do we synthesize all of that information using these emerging technologies? Because we know that people are using natural language, even more so now than before. People expect to be able to ask a question and get an answer. And so, in the science world, being able to, find things through keywords, semantics, metadata isn't necessarily how that information is going to be used by an end user decision maker, whether that's in emergency management or insurance and such. And so really trying to bridge the gap by using these types of natural language devices. So our Voice Atlas software, this is just kind of showing you the back end of what that looks like. You can have lots of different types of data sources. So you can have documents, you can have websites, you can have information that you've put here yourself. You can see that as the knowledge manager, you have complete control over what are the sources of information. We don't allow Voice Atlas to go outside of that. So literally, if it's not in your knowledge base, it's going to tell you it doesn't have information. It doesn't go to its training data. We don't send any information back to any LLMs. So it's a very safe and secure way to use AI when you're looking at data. In this case, you're seeing just a quick question in our playground about what are the data sources. So this is really crucial, I think, for AI applications, is that we make it very transparent how the AI is coming to get a response. And that's one of the things that we are very proud of with what we've built with Voice Atlas, is that we give you that transparency by providing the information and then allowing Voice Atlas to actually cite its sources, both on the back end and on the front end for the user. So this is crucial, not just for open science, but also, for us as a society, as we go forward, to be able to have AI systems that are fully transparent and that can document their workflows and the provenance of their information. This is just an example of some of the types of things that we can ask in terms of lessons learned. So in this case, it's distilling information from across all of the different sources and specifically from that after action report. And then I'm going to show you this all coming together in the visualization itself. So, here's an example of the game engine visualization. What's really different here about what we are doing versus, just the way that fire is often characterized is that we're also bringing in the containment. So here you're seeing, all of the information that was available about the prescribed burn, the wildfire that ensued, but then also the containment, because we know that a fire doesn't just exist in a vacuum. There's also human efforts to control that. And so that was one of the things that we were very pleased to have validated by the fire community, was that they said, you really captured not just the fire behavior itself, but also the fire behavior in response to what were the containment strategies. You can see over on the right-hand side also, Voice Atlas is the conversational interface answering questions about that. And so it's, answering questions about the data. In this case, even just something as simplistic as what do the yellow lines mean in this visualization? So it's a very useful tool for answering questions at many different levels. Here's a QR code. So if you actually want to play around with the Hermit's Peak visualization, you can do so. I'll give you a second so that you can actually open that up on your device if you'd like to, or I can share links afterwards. And you'll see in the lower right-hand corner, it will open up Voice Atlas, and you can, ask different questions and get responses about this specific project, about this visualization. Again, all of the after action reports are in there as well. You can play around with that. All right, so the second case study that I'm going to highlight is from the more recent Los Angeles fires, the Eaton Palisades fires. And, these, I don't need to tell you, what a catastrophe, just on so many different levels that these historic fires were. And so this is showing you a compilation of some of the visualizations that we did for these events. bringing together lots of different types of data sources, also showing the extreme wind events that occurred to cause these fires to spread so quickly. And so I wanted to show you the visualization and isolation that was used, creating the Unity game engine, but then also, again, showing you how that works when we bring in the conversational AI component. So here's a different QR code for you. Again, if you after the session or what have you, want to open this up. In the lower right, you'll see Voice Atlas running. We've kind of nicknamed it here Firebot, and you'll be able to ask questions about the fires, about the visualization, just as, again, it's kind of showing you being able to distill information from, 800-page reports, down into, some key findings, also citing sources, giving links, allowing you to get a next step, which I think, again, is just so important, so crucial. After each of these events, how many times are these reports going to be written and filed somewhere, and then those lessons learned aren't actually applied? So hopefully, this is an example of how we can marry these two technologies together to help people to understand not just the events that occurred, but then also how do we make better decisions for the future. These visualizations, we were honored to actually have them included in a couple of documentaries that were put together about the LA fires. I realize here this is not a clickable link for you, so I can copy and paste these links into the chat afterwards and send them out. The documentaries really do an amazing job of telling the story. And it's, very cool to see them kind of toggling back and forth between our sort of cinematic data representation, all put together based on data, and then going back and forth between imagery that was captured by people from, cell phones or stationary cameras on towers and such, and really being able to see the fidelity between how the data, the animated sequences really show, what happened, helping people to understand that. So the future of this, is hopefully being able to take these case studies into more of a productized approach to really be able to help people finding that information from multiple sources, complex environments, having that AI be a trusted source, not just, having no idea where the information is coming from, but being able to control and cite the sources that will help get that information out of silos across, multiple organizations, making that knowledge much more interactive and hopefully laying the groundwork for decision-making tools of the future that use advanced data visualization techniques and also the AI component that can be that trusted assistant. This is my contact information. If you're interested in Navteca as a company, and then also our Voice Atlas software. And I look forward to continuing the conversation.
Well, thank you, Shay. And I think it mirrored much of the discussion that was going on in the chat about how do I trust this? Is AI going to make things more trusted or less trusted? I think you addressed a lot of that, where the technology is accelerating the merging of data, but also showing where it's coming from and what to believe and what not to believe and how to mirror where the improvements need to be. And as you said, and I hope the progression of talks today showing how that the technology can be linked to people and answer that, as we talked many, many times about the so what of the technology. I really am impressed by how far this has all come. Let's pivot over to hear from Guy. He's also touched on many different peril areas and has some perspectives on imaginative ways of using data and where AI is going. But it'll also connect up with the flood situation and other implications here, which should be very relevant to the fire, because I think we're seeing more fire and flood and land change all coming together really for the first time, again, augmented by AI. So Guy?
Yeah, I hope. Thank you. It's really a pleasure to be here. I mean, it's great. I think I met most of you at some point in my career. I came across you. I worked a lot with projects that David funded on the flood side, but also the latest one on fires as well. I just want to show you here what I'm really all about and what David has enabled as well, because I think it's some of this actually come into operations only out of research about now. So it takes a long time to go from this research that NASA and ESA is funding all the time to go into something really truly operational. I guess more in line what FireScore is showing and what others have shown, more kind of, what is needed in the field, what is needed for property protection, resilience building, and of course AI has its place. I'm trying to go through a couple of things where I see this thing going in flooding and flood alerting. There's a lot we can talk about, so I left my email as well. Just email me and we can chat about things. I'm always available for chat. And Alex, we really should connect. I know you've sent me messages, so it's really great to be here today. So I'm going to go through what we call MOM or MOM or Model of Models. This is kind of what David started to fund, and it's really, I'm glad to report, about more than 5 years on, it started now to be used operationally by organizations we didn't imagine would actually use that thing. So, because it's actually working operationally. And I'm going to talk about multi-sensor AI-aided satellite Earth observation application. I put apps because it's a new world, applications or apps, but we should develop things that can integrate with any device, anywhere, and talk to anyone. That's the big thing, actually. So how do we then move from a raw satellite image to a real insight or a raw model image, or how do we move from that to a real insight? So how do you move from a map, a traditional 2D flat GIS map that is very scientific based or engineering based, to kind of a pin? I call it a pin because imagine you're driving in your car, you see the Google map on your dashboard, you get these pins when you drive along. Suddenly you have a charging station lighting up as a pin, you have a restaurant, you have McDonald's, Starbucks, whenever you get these pins. So how about a pin of a hazard, forecast observation, direct feeds? But then we need to work a lot how to transform 2D information into like a fraction of a kilobyte important information that can be transferred anywhere to anyone. Who are the real end users? Working with David over the years, he's been pushing think about who's actually using your stuff, who will be using it. And actually, when you're doing these research projects with NASA or ESA or European Commission or NSF, no one is using the stuff. Actually, when you do the project, because you're not very sure. So unless you start the other way, what a lot of people today have been showing in this session, like Alex, and also all the talks have been talking about, try to first get an understanding of what is needed in the field and then go back and do the research based on that. So how do you make these insights clear and fast and affordable? Because nobody has a big budget when there's a disaster and they want information, unless you're talking to governments of United States or maybe Europe, but nobody else has that money to buy data when it's really happening and needing. So maybe there's time for what I call a data cocktail. Mix all the data in, and out comes your little pin with all the clarity of information using LLM and whatnot. Maybe it's possible. But let me start a little bit back, but I think you all know this one. It's a famous or infamous disaster cycle. So you have mitigation, you have preparedness, you have response and recovery. And in each one of those phases, there's a place for everything we talk about today. So I don't think I will dwell a lot on this. I want to get a bit into preparedness maybe, because there's a lot of preparedness and response. There's a lot of stuff we do at RSS Hydro out of Luxembourg, but we do it globally. And also with the company I'm associated in the US, ImageCAD, and also with NASA projects, ESA projects, we do all this stuff. What we actually use is things like MOM, which was developed by a project funded by NASA. And, I think Maggie is talking after lunch or even in a different room right now, I think. So Maggie Glasgow from JPL, she was leading this with myself and others that are actually, I think most of us are in this conference right now. We had PDC, Pacific Disaster Center, as an end user triggering this request, I guess. And David was really good enough to fund it. And as I said, it works. It was then used by UN as well, WFP, which is now kind of, disintegrating a bit with their platform on these kind of things. But that's another story. I mean, there's time for maybe the community to step in a bit and take some of that load. And that's what we're doing right now at our society. We're taking that model of models, putting it into higher granularity, seeing if we can build it out country by country specific, seeing who's willing to support this. It's already, the global version is already running in a small server at the Met Office of Indonesia. They've just taken it. They pulled it off GitHub. They're using it. They're very happy with it, but they know it's not working every time when there's a disaster, but it's really good. They're using it. And then there's things like FlatHub from Google, the AI model that works really well. They published in Nature, getting better results or similar results to ECMWF and NOAA forecasting. So it's really working well. It's more in line how people expect the results to be shown, of course, because it's a corporate company that really talks more to the end user and is, its business is oriented towards every single person. So when they develop things, they probably make sure it talks to everyone, which is important. We also work a lot with NVIDIA and other big techs, although I'm in Luxembourg, we work a lot with NVIDIA Oracle to do actually what Alex was showing, this 3D dynamic visualization, almost looking like a Pixar animation, but it really, really helps convey the message to non-experts, what you're doing. So it's all there. And, there's nowadays the question, how is the disaster cycle, how is all this information and space information connected to dual use technology? Like civil security, resilience, protection, how is this linked to defense? Maybe in the US, that's a lot clearer because there's always the DoD stepping in when there's a hurricane. In Europe, defense and civil security have been until now very, very separated. Unfortunately, because DoD can really flow a lot of cash faster when it's needing for disaster. So, but we all kind of changing in this current world. So maybe that's helping a lot, combining the two sectors. So over the years, I've been complaining about things. You can read some of the things I've been published like more than 10 years ago. The first publication that actually won the editor award, this assisting flood disaster response with Earth observation. I was complaining so much, I called it a fire hose of data. We should stop this, go to a one-stop shop, or create something that the community could actually understand what scientists are doing. So I've done all this. Nothing really changed until we had this MOM opportunity. So it's basically a forecasting tool, but it's not inventing any new forecasting models. It's taking open source models that are truly 24/7 operational from the US, from Europe, or from elsewhere if they have that criteria. And it's producing all that complexity into, inside it's really difficult how it works to explain, but outside it's just simply streams those things into clear outputs, which means sub-basin related coloring of a basin based on probability or forecasting of all these models that run inside. It can run on any server, any platform. We're now putting it in Dockers. We're now doing it country specific. So that's where my company right now is helping a lot, but we keep it open source. So anybody that wants a Docker can have it. But what we are building into the commercial sense is a service out of that. So a reinsurance wouldn't use the Docker to run on a server to produce a scientific basin output. They want a service from it. So there's still this commercial and that we still need to address. And then in terms of satellites, when we see where we are, we're still very old school. Like every company still sells this single pixel raw data. Give me $1,500 and I task my satellite, I give you a raw image or raw pixels. Well, that's not great. That's not helpful, because if you are a driver in a truck for a company that has just tasked that satellite, how is that company going to inform the truck driver that there's a flood in the area he's going to hit? No idea. It's raw data. It's a pixel. It's not easily transferable, and it first needs to be interpreted. So first, why don't we move towards a mix of data, so multi-mission satellite Earth observation, so when David was still at CEOS, he was talking about this GEO-LEO-SAR, although SAR is also LEO, but you know what I mean, geostationary, MEO, or was it GEO-MEO-LEO? Maybe, David, that made more sense. I don't know, probably that's what it was that you said, but it stuck with me. And we have a PhD student now, actually, that's exactly doing that, taking geostationary data, taking MEO data, taking LEO data, taking any kind of spectral wavelength, and saying at any given time when there's a flood, there must be a satellite up there that's passing over it. Maybe not acquiring an image, maybe it's a data, maybe it's an atmospheric sounding instrument, maybe it's a GPS passive receiver, but it's something in the public domain that we can use and interpret to a flood. It's a PhD, so Chloe will take some time, but she's managed to publish some of it already, so it's kind of working, so we can do that. And then if you think about combining this observation with the forecasting of models, you can think of the model could actually task an acquisition, or vice versa, the satellite observation can actually verify the forecasting, update the weights, and run again. And then if you take the Google kind of principle and put an LLM underneath any forecasting, you can actually start what we've just seen in the other presentation, just people, this Firebot, why not have a Flatbot and people chat and it's actually the MOM or the satellite application running and anybody can talk to it. Here's some snapshots of what we're doing. So upper left, that's the model of models output. This is the global version, but you see the coloring. Green, nothing is happening. It's just informational, all the data that's contained. So you click on a basin and it opens an attribute table like you used to in a GIS. And it explains to you what's happening in that basin in terms of a flood alerting. And then when the colors go to red, of course, you have to bring an action in place. Probably when there's yellow, you should prepare. When there's like orange, you should really get started to mobilize. And when there's red, it's kind of you need to know what you're doing in terms of warning, action, alerting. So that's also when I was talking to Indonesia Met Office, the exercise we did. Visualize this in Google Earth Engine. It's really fast. It outputs on GitHub. Right now, it outputs every day. Every 6 hours, it runs a new forecast, new alerting, up to several days ahead. Using ECMWF GLOFAS, using Maryland GFM running on NOAA data, using the Hurricane Center model, using all sorts of forecasting. And also now we will implement the Google Flood Hub API as another model. It readjusts the weights and then it uses a satellite verification when a satellite image overpasses and it requires a flood. And this goes into a map. It takes that data to verify, readjust the weights and runs again. It sounds very cool, but it was a lot of work. And actually it's very robust because when we start losing kind of some models, it still keeps running because it's using enough models to not rely just on one. We've published papers on it as well, so scientific papers. But now think about the PhD I was talking about, multi-missions. So if you have a refreshing observation, right now we can do up to twice per day, anywhere in the world. And this is showing you these upper rights are showing you South Korea, big region flooded last year. We were asked by K-Water in South Korea to basically run our PhD application algorithm that we have. This is passive microwave downscale to 30 meter. It went through clouds. Sentinel-1 SAR was not overpassing. And the only image available was very high resolution, very low coverage, low spatial coverage RadarSat-2 RCM missions. It was not enough to cover the whole area, so we were asked to do that, and we did it. We even detected in urban areas downscaled. And now if you think about this, and you can now have NVIDIA technology or any other open source stuff, and the NVIDIA visualization tool is also open to use. It's called Omniverse, so we can use that to take that very boring looking reddish kind of flat map into a visualization like this. So people don't understand the red map, but they certainly do understand this high resolution visualization that you can do. And when I said pixel animation, indeed, the waves here, the ripples you see on the water is of course not the one from the map, but it's to give the map this reality looking feature that nobody will ask you a question what that is. That is clearly flooded water. And I don't know if you can see it on screen, but you can actually depict the electric pylon out of the water. And that's real. So this geospatial geolocation is real. The map is real. The only thing that's faked or animated is this real feel effect. And this is where you get everybody to go, wow, okay, this is great, we need this. Actually, they always needed the map. They just didn't know it was actually helping them to understand something like is shown here. And then we've also implemented that easily everything in a Docker, so you can run, you get the satellite map, but what is not Dockerized yet is the visualization. It's very difficult to do that. But we're working with NVIDIA to seamlessly integrate the above into a visualization. It's also not cheap because it needs a high GPU acceleration to render these visualizations. Anyway, so when I go to talk about raw images, we can now create maps. But how about we take this map of the Texas event on the left? That's a very high acquisition image, a very high resolution one. We process that with a satellite application algorithm. But then we move to something that's a pin here. So this is the dashboard of your car on your phone. And this red pin contains now information about this whole flood destruction that you see on the image. So let's think about it a little bit. I published the idea online. You can read up on it. Let's say the attribute everybody wants to know is where is it? So that's a latitude, longitude. But what is it? How big is the flood actually in terms of extent? What's the level of impact of the flood? And what's the uncertainty of our analysis? And how confident are we that all the above provided is actually correct? So we did actually run the experiment on this Maxa image. And out comes this, is the centroid of the flood, is the radius of the flood in meters, is the impact level of the flood, is total destruction, so it's 5. Uncertainty of the analysis that we got this rightly interpreted because we're using ML, so we have an implicit uncertainty, it's 20%. How confident are we? Well, we're bloody well sure that this is the case, so it's 90%. And this message now weighs 0.2 kilobytes. This means you can send this from space to any device, to any other satellite, to a geostationary, then get it down to anywhere you want through navigation satellites, to telecom satellites. And you can even, you should be able to send it with Bluetooth technology. Even these things exist now from space. There are a few companies doing that. You can send it direct to device or anywhere you like. So we're working now out if we can do this, who are the customers? Because it's literally anybody. Because this message, anybody understands that. A firefighter can take a radio that out. These numbers are clearly interpretable. You just need to know the attributes behind it, and that's it. No more image, no more map, no more scientific complexity. So who are the end users? As I said, it's everybody. It can be everybody, but Nano Bananas left it white here, left it blank. It's people. I wanted it to put people in there, and it wouldn't. And that's no joke. It wouldn't put people as the end users, but I think it's everybody.
Trained on too much science data, guy.
Yeah, I guess so. It didn't go for people. Anyway, it should be people. So why am I doing this? And I think Firescore can relate to this, working with firefighters a lot, and people that have also with the other fire talks we saw, they work a lot with firefighters. I went to a few fire conferences and also to talk to firefighters. All they really want is this simple, fast information that really makes a difference. So because we could set with this new standards, new precision, new scale, and probably new relevance is real time. And this is the kind of data cocktail I was talking about. Why don't we move into a cocktail of data? Get away from the image, but use any possible EO data, interpret it, and put it into the same kind of output, which is this text-based ASCII file. And of course, the power of location and communication, that's all it is. It's where is it and how do you communicate that? And as I said, it took me many years to figure that out, but that's the secret sauce, I think, for anything we've seen today. And I'm glad to see others are way ahead of me. They are already working on this kind of model. And then we can be really disruptive. We need to be disruptive with EO, with the business model. We have to stop selling half an image for $2,000 that is not having an analysis on top. Maybe that's good for defense, but it's definitely not good for the normal person that's being flooded and whose livelihood is lost. So we need to get to from a data cocktail to an intelligence pin. And, it's all about this. How do we create value and impact? And talking to David, it really triggered me again. It's like this, the sovereignty of data, AI, we all talk about this. We know that role of government is changing. Now, who is now responsible for what to be maintained? Is it NOAA? Can we rely on these agencies, or is it ECMWF? Probably they need a budget to do all this, but maybe it's time for a new community. We should all step in and help out. And what is the big future? And I think I just presented it, hopefully, to you, but maybe the internet is watching. I don't know. So this is it. I think this is what I have to say. I'm sorry if I went a bit over time, but yeah, thank you very much. And keep on emailing me. Thank you.
Thank you, Guy. That was perfect. And I'm sure Shana is now starting to work on the flood bot. And
yes,
Firescore is ready to work with you on the visualization.
Yes.
And Rob is ready to figure out how to get it to the insurance and property community. So I hope you see this well-crafted community story that was intended to be part of our dialogue today. And your questions at the end set us up right for a discussion, which I hope you will all be able to stay on for this afternoon, if you will, part 2. And I've also have invited the disaster group that has been talking simultaneously with in another room, hopefully to come over and join us. Maggie and Dave Jones and the others to continue to talk about this hazard. And really those bigger questions now, if we've seen what's possible, you've all shared some insight as to, I think everyone here found a way to collaborate with each other. I hope it can really happen. I wish I was still in the position to fund all of you and prompt you all, but I'm committed to making all these things work. And I think what we'll do is we'll meet up again in another hour or an hour and a half. Rachel, what's the time till after? It's an hour, right?
It starts at 1:30. 1:30.
1:30. All right, Patty. Thank you, Patty. And then we'll 1:30 Eastern time. We've got people in Spain and Luxembourg here. So on the East Coast and West Coast, US. So we will meet again. We'll try to address some of these next steps. What are some steps for ESIP? What are the changing roles of government? What are the changing roles of data availability? What are some of these data commons and catalogs? What about digital twins and new ways of training and educating, which we haven't even yet talked about, a new workforce, a new educational, and maybe the role of the community. So we've gone over a little bit, but I really thought it was a great discussion, and I really very much appreciate everyone's thought and patience, and I look forward to meeting up with you again this afternoon. Thank you.
Thanks, everybody.
Yeah, thanks, everyone.
We'll have more chance for discussion. And I'm going to ping Everett and some of the others and Marge to kind of also ask some questions, and Alex to continue visioning for all of us.
And I just want to comment that, this is a flywheel, and collectively on this call, we all took a turn on moving that flywheel. So it's these conversations that really get that spinning, and it's not just one that creates magic. It's over and over and over. So let's definitely continue staying in touch, and looking forward to hearing on the great progress everyone is doing. So this was very, very nice. So thank you all for coming on today.